Welcome back, everyone. Today, we are taking a deep dive into network routing,
Oh, yeah.
specifically how data zips across the internet.
Fascinating stuff.
We'll be looking at a C program that simulates the distance vector routing protocol.
You know that system that helps routers find the best path for data packets?
It's like those tiny digital couriers,
Yeah.
and they're trying to figure out the fastest routes.
Exactly.
And that's what we're exploring today.
Absolutely.
Okay, so we have this C program, and I know at first glance it might look intimidating,
Yeah.
but it's actually quite elegant once we break it down.
Very true.
Let's start with some of the key elements.
Okay.
Right off the bat, we see infinity defined as 99999. So what's that about?
Well, that's just a clever way to represent destinations that are unreachable at the moment.
Okay.
Like saying, hey, getting there is basically impossible right now.
Oh, I see.
Then we have max set to 10.
Right.
And that defines the maximum size of our simulated network.
So like the number of cities our couriers can travel between?
Yes, exactly like that.
And then we have the heart of it all. The cost, dists, and next hop matrices.
Yeah,
These are the brains of the routing logic.
absolutely.
Can you tell us a bit more about what those do?
So these matrices are like the router's personal roadmap.
Okay.
Imagine a table that the router keeps.
Okay.
Every row is a destination,
Got it.
and each column represents a possible path to get there.
Makes sense.
The cost is like the price of taking that path. Maybe it's a congested route, or maybe it's a long distance connection.
I see.
Dist is where the router keeps track of the cheapest routes it finds,
Okay.
and it's always updating as it learns more information.
Interesting.
And next hop is like the signpost.
Okay.
It tells the router where to send the data packet next to get it closer to its destination.
So our program is setting up the network,
Yes,
and it's giving the routers a way to figure out where to send things.
that's right.
What happens next?
So next we have the initialize function. And this function sets the stage by establishing the initial distances based on direct connections between routers.
Like when a network admin physically connects two routers with a cable.
Exactly.
This function represents that initial setup.
Yes, precisely.
So it's like drawing lines on a map between cities.
Yes.
The shorter the line, the lower the cost to travel between them.
Exactly.
But here's where it gets interesting.
Definitely.
We move on to the update routes function.
Yes.
This is where the magic of the distance vector protocol really comes to life.
Right.
We're getting to nested loops here.
Okay.
A core programming concept.
Yeah,
But this is the heart of this routing algorithm.
it is.
What's happening in those loops?
Well, imagine our routers are like a bunch of gossipy friends. Each router starts with information about its direct neighbors, the paths it knows for sure,
Right.
and then they start chatting, sharing their routing tables with each other.
Oh,
As they share, they compare notes and update their own tables based on what they learn from their neighbors.
Interesting.
And this keeps happening over and over again until everyone has the most up-to-date information.
so they're comparing notes to find the most efficient routes.
Yes, like finding the best shortcuts through a city.
Exactly.
And that's the essence of the distance vector routing protocol.
Okay.
Each router is constantly gossiping with its neighbors,
Right.
updating its table based on the latest intel.
Hmm.
This process eventually leads to a network where everyone knows the best routes.
Gotcha.
Now, this gossiping might sound haphazard, but it's a really powerful way for a network to adapt,
Yeah.
especially if something changes. Like, what happens if a link goes down?
Oh, that's a great question.
Yeah, if a link breaks, imagine a road closure in our city analogy.
Hmm.
The routers connected to that link will realize they can't reach certain destinations.
Right.
And they update their tables accordingly.
Makes sense.
And then they share this information with their neighbors and so on.
Okay.
Eventually, the whole network will adjust to the change, and everyone will reroute around that broken link.
That's pretty cool.
It highlights a key characteristic of the distance vector protocol. It's dynamic.
Okay, so we've got our routers setting up initial connections.
Yeah.
They're gossiping and updating their maps,
Uh-huh.
finding the best routes.
That's right.
What's next?
Well, we need a way to see all this routing information, right?
Yes, of course.
That's where the display function comes in.
Okay.
It presents the calculated routing tables in a format that's easy to understand.
So it's like printing out our map with the best routes marked.
Exactly.
So in a networking lab setting,
Yeah.
you could run this program
Right.
and you could tweak some parameters like adding more routers or changing the cost between them.
Uh-huh.
And then you could use the display function to see how those changes impact the overall routing paths.
Exactly. It's a fantastic tool for learning about network routing in a hands-on way.
And what's really remarkable is that this relatively simple C program
Right.
with its matrices and loops
Yes.
It provides a foundational understanding of how the internet functions at a basic level.
Absolutely.
Countless routers around the world are doing this very thing right now, using algorithms like the distance vector protocol to deliver information to your devices.
It's amazing.
It really is mind-blowing.
It is.
This seemingly simple C code has unveiled the inner workings of the internet.
Yeah.
This deep dive has only scratched the surface of network routing.
True.
There are more complex algorithms out there,
There are.
and the internet is constantly evolving.
It is.
But hopefully this exploration has sparked a curiosity in you
I hope so.
as you continue your journey in computer science.
Yeah.
Consider this. How might these routing algorithms evolve as we move towards even more complex networks? Networks with billions of devices connected to the internet.
Fascinating question.
Keep that question in mind and see where it leads you.
Great advice.
That's all for this deep dive, folks. Thanks for tuning in.
See you next time.
Until next time.
Bye.
Bye.